are going to start talking about implicit differentiation. And it's important to realize that we've actually been doing implicit differentiation um, in its simplest form without even realizing it. Differentiate, tough to talk and spell at the same time. Differentiation. Um, so let's refresh our memories a little bit. And I stress notation a lot in my videos and when I teach and everything. So let's look at something like this. Y equals 3x squared plus 5. And keep in mind the importance of notation. If I'm taking the derivative of this, you really have three options. You can say the derivative of y with respect to x is equal to 6x. Or, more simply, you can say y prime equals 6x. Or, another popular form is dy dx, very similar to this first form, equals 6x. Think about what this really says. This is really saying that the derivative of y is y prime, or dy dx, or this is the derivative of y. And that is equal to 6x. Okay? So this tells us we've taken the derivative of y. This no longer is x comma y. This is not the vertical component of a graph. This is not the coordinate y. This is the slope, y prime, dy dx. That represents slope. So it's important to recognize that. Let's look at our first example. Let's suppose I give you x times y equals 1, and I ask you to find the derivative of that. Well, hopefully you say, hey, gee, that's the same as 1 over x. And hey, gee, that's the same as x to the negative 1. Well, that's the power rule. Y prime equals negative x to the negative 2. So my derivative is negative 1 over x squared. And that's all fine and dandy. Your other option, which we now have, since this right here is what's called an explicit equation. Explicit, it is y in terms of x. Okay, y in terms of x, a traditional equation. Okay, this form right here is called the implicit equation. Sometimes I cannot change a implicit into explicit form. So let's say I can't change it. This is now a product rule, right? We have two functions, x and y. Call them f and g. Product rule says that f g prime. Well, what's the derivative of y? All along it's been y prime or dy dx. I favor dy dx. So I'm going to write x dy dx. So f g prime plus g. Now f prime, think about it. The derivative of x is 1. Well, let's pretend we're taking the derivative of x the exact same way we took the derivative of y. Instead of dy dx, it'd be dx dx. And dx dx is exactly the same as 1. How about them sound effects? 1. Okay, and of course the derivative of 1 right here, derivative constant, is 0. So I end up with dy dx is equal to, and I want to subtract y and divide by x. That's my derivative. Now my derivative, notice, is in terms of both x and y. In this case, since I can rewrite y as a function of x, I could substitute in here and say that negative, here comes the substitution, 1 over x over x. And that's the same as negative 1 over x squared, which we got over on this side. So bottom line is, we don't need to be able to rewrite it as a function of x. We can take the derivative implicitly. Let's look at a more complicated example. And in fact, we'll kind of build our way up here. So the derivative with respect to x, that's this d dx of x cubed, is 3x squared times the derivative of x, right? The chain rule says the derivative of x. Well, the derivative of x we never worried about because it was just 1, and we still don't need to worry about it if it is with respect to x. But what if I try to take the derivative of y cubed with respect to x? Power rule says that's 3y squared. Chain rule says times dy dx. How about you try this one on for size? d dt of x cubed. Well, that's going to be 3x squared by the power rule. Chain rule says it's dx dt. t. d d g of b cubed. That'll be 3b squared. That's power rule. Chain rule says db dg. Okay, so common ones that we will see, velocity, dv dt will come up, velocity or volume, or ds dt, or dy dt, or dx dt. All right, this is the derivative of v with respect to t, the derivative of s with respect to t, the derivative of y with respect to t, and the derivative of x with respect to t. Okay, with respect to t. This is with respect to x. This is with respect to t, and this is with respect to g. Okay, let's try this one for size. What is the derivative with respect to g of g cubed? Well, that'd be 3g squared. And then technically, chain rules say dg dg, but we know better than that. dg dg is I forgot the sound effects here. There we go. All right, so keep in mind how the variables match up. If we're taking with respect to g of g, then that derivative is simply 1. All right, so let's jump right into this guy here, and let's find a nice example here. Find dy dx. Given y cubed plus y squared minus 5y minus x squared equals -4. So even if you wanted to, you cannot solve this for y. Okay, not in terms of x. I mean, sure, we could say y equals, but we'd end up with a plus or minus square root of something that has a y in it. So not helpful, but implicitly helpful. And again, notation is important. So when we take the derivative, we get 3y squared. Chain rule, remember, says dy dx. Plus 2y. Chain rule says dy dx. Minus 5 dy dx. Minus 2x. I'm not going to write dx dx because we know that's 1 equals 0. All right, so now this says find dy dx. Well, here, I found it, all done. Now what it really means is solve for dy dx. So I have dy dx in 3 terms, so I'm going to take it out of 3 terms. Factor it out, I have 3y squared plus 2y minus 5. And I'm going to add that over there, equals 2x. And finally, dy dx equals 2x over 3y squared plus 2y minus 5. Now it's an ugly derivative, but keep in mind what that means. That is the equation for the slope of the tangent line for this equation up here, for this expression, y cubed plus y squared minus 5y minus x squared equals -4. Okay, for that implicit equation. Think back to when we've done derivatives before. I've given you equations that said find the tangent line at x comma y, at those 2 points. And we've always used just the x to find the slope. We use the x and the y to find the equation of the line then. Well, now we're going to use both x and y to find the slope as well as to find the equation of the tangent line. Okay, so let's do one more example here, and we will do this as a determine the slope of the graph. Let's find tangent line. Find tangent line. At the point 3 comma 1, and we will do what's called a lemniscate. A lemniscate, a pretty cool looking graph. If you want to look that up online, it's pretty neat. So the equation is similar to that of a circle, the x squared plus y squared piece in there, but it's squared. And that was an equal sign, equals 100xy. So derivative, this looks like a power rule with a function inside, which means chain rule. So we have 6 times x squared plus y squared, drops to a first power, times the derivative of the inside. The derivative of the inside is 2x plus 2y dy dx equals, so I'm going to look at this as 100x and y. So in other words, f and g. This is a product rule, clearly, but I'm going to put 100 with the x. So f g prime plus g f prime. And now I'm not going to waste my time in simplifying. I'm going to plug in 3 for x and 1 for y. So I have 6 times 9 plus 1 times 6 plus 2 dy dx equals 300 dy dx plus 100. And we'll go through and solve this. This is 60 times 6 plus 2 dy dx. Remember, dy dx means slope. So I'm looking for the slope right now, 300 dy dx plus 100. Distribute 360 plus 120 dy dx. And you can see this coming together here a little bit. 300 dy dx plus 100. Subtract 120, I get 180 dy dx. Subtract 100, that's an ugly 100, 100, and we get 260. Divide by 180, I get 260 over 180. That's dy dx, and of course that can simplify 26 over 18, and then it goes to 13 over 9. So let's scroll down a little bit here, see if anything disappears on us. See if it even scrolls down. There we go. And certainly things are disappearing there. Plus sign's not a plus sign, so let's go forward. Backwards, bring everything back, scroll down, and I have y minus 1, right, our x coordinate, if you look up top here. 3 comma 1, so y minus 1 equals m times x minus the x coordinate. So I get y equals 13 over 9x minus, this is 39 over 9. And I want to add 1. I'm going to add 1 like this. There's my 1 I'm adding. So final answer, y tangent equals 13 over 9 x minus 30 over 9. And that is the equation of the tangent line to the lemniscate. Okay, so that's what we're looking at here for implicit differentiation. Not a whole lot new stuff. It's just different. So take your time, practice it, and you'll ace it. Have a nice one.